Well, hello, Six. Just a quick worked example to get you back in the swing of things after a couple of weeks of different stuff. It's KP practice. This is question 1 from the sheet that you can find in the shared folder. Just going to go crack straight into it because I think I would have chatted to you already at the start of the lesson. If you see a question like this, first of all, just note appropriate number of significant figures. When's the best time to approach that? At the end or at the start? Well, you might think at the end. I'm going to tell you at the start because you can figure it out now because you've got the data you're going to use in the question, and you're not likely to forget at the end, but there's a chance you'll forget at the end. I think there's less chance you'll forget at the start. So get it done now. All right, number of sig figs. I'm looking at the data I'm going to use in my calculation. Okay, so technically it's best to look after the calculation because you see what data you used, but in practice you could probably think that you're going to be using this data. 4 sig figs of PCl5, 3 sig figs of that Kelvin, 3 sig figs of the kilopascals, 3 sig figs of the moles there. Okay, so you've got a mixture of 3 and 4 sig figs. How many sig figs are you going to give the answer to? 3 sig figs, because 3 is less than 4. So 3 S F. I'm just going to write somewhere near where I think I might have the answer of my final calculation. Okay, less chance to get it wrong. Let's see if I actually miss that when I get to the final answer. Okay, so we've got this equilibrium mixture, and they want to know something about the equilibrium constant, the value of the equilibrium constant. I might as well give the units as well, just to be safe. So I know that's about a system at equilibrium, so I really need to know about that equilibrium. I need to know the moles of what of each of the substances at equilibrium, and because they've asked about Kp, I also need to know the pressure at equilibrium, which they've told me of 625 kilopascals, and that allows me to work out partial pressures, as I'll show you. Okay. So initial, change, and equilibrium, do my ice. That's a nice fail-safe way to be able to work out the number of moles of everything at equilibrium here. So I've got 1 mole of PCl5 vapor and nothing else. Okay, very important that we're starting off with none of the PCl3 and Cl2. That's part of it. And at equilibrium, I've got 0.6 moles of chlorine Cl2, 0.6. Okay, so the change in Cl2 must have been plus 0.6. Okay, what else is going to increase as we increase the Cl2? Well, the PCl3 will have. And it's a 1-to-1-to-1 ratio all the way through this. So PCl3 is also going to increase 0.6 moles of it. And because it's a 1-to-1-to-1 ratio, if PCl3 is increasing by 0.6, PCl5 is decreasing by 0.6. Okay, don't think 0.6 plus 0.6 is 0.12. No, 1 molecule of PCl5 is broken down to make both a molecule of PCl3 and a molecule of Cl2. So this goes down by 0.6, not any other amount. Okay, so 0 plus 0.6 for PCl3 is also 0.6 at equilibrium moles. And PCl5, 1 minus 0.6 is 0.4. Okay, so I've got my equilibrium moles, perfect. So I'm on my way to being able to get Kp. Kp is equal to the partial pressure of these gases times each other, so in a product over reactanty way. So pressure of Cl3, that partial pressure of PCl3, sorry, times, not square brackets here, because square brackets are exclusively used for concentration. Okay, don't put square brackets, you will get penalised. The partial pressure of Cl2, come on pen, I'm on the screen, so, divided by the partial pressure of PCl5, okay, products over reactants. Partial pressure of PCl5. Alright, well, what's the partial pressure? Well, the partial pressure of each thing is the mole fraction times the total pressure. Total pressure is fine, I know that, 625 kilopascals. What unit should I use? Well, I should probably use either kilopascal. In this case, actually, because the moles is a unitless amount, really, I can just carry on using kilopascals the whole way through and quote my answer as kilopascals. If I was going to be safe, I would, with any calculation, use pascals and then quote my answer in pascals, because that's the SI unit, and that's what's going to work with PV equals nRT. Although I'm not doing PV equals nRT here, but that's not the point. It's a good kind of system to get into. So let's change colour pen. Mole fraction first. Number of mole fraction. Mole fraction is number of moles divided by total moles, and we need to calculate it for each thing. That's the mole fraction. So for PCl5, it's going to be 0.4 divided by, well, total moles here is going to be, this is in the whole mixture, so everything together. Now that's all mixture. I can't separate my product and reagents in this like vessel, so they're all mixed together. 0.6 plus 0.6 plus 0.4 is 1.6. So 0.4 divided by 1.6 is that mole fraction. These mole fractions are 0.6 divided, that's a 0. 0.6 divided by 1.6, and this is 0.6 divided by 1.6. 1.6. Okay, there are my mole fractions. Now, my partial pressure of PCl5 is going to equal my mole fraction times the total pressure. So 0.4 over 1.6, or 4 divided by 16, which is 1 over 4, isn't it? So it should be a quarter. Times by the total pressure. So total pressure here is 625 kilopascals. I'm going to be well behaved and use 62500 pascals. And that's going to give me a partial pressure of, do the sums, 0.4 divided by 1.6 equals a quarter, times it by 62500 equals 156250. And then to get Kp, I'm going to plug in all these things. So that's PCl. It makes it look like 3 I've drawn, but it's PCl5. I hope I said PCl5. That's the partial pressure of PCl5. Is that number 156250? So I've got my pen. Now I'm going to do the other guys as well. The nice thing about the other two versions is 0.6 divided by 1.6 is the same both times. So the partial pressure of PCl3 is going to be the same as partial pressure of PCl2, because they're both the same number of moles in the same total number of moles and with the same total pressure. So it's all going to equal the same. So let's try that. 0.6 divided by 1.6 equals, times by 625,000 equals 234375. 234375 squared, because I'm saying that the pressure of this is equal to the PCl3 is the same as the pressure of pressure of chlorine. So that's the same as squaring if I'm targeting the same thing by the same thing. So if I square that, it equals an answer 5.493 times 10 to the plus 10. Divide that by my 156250 equals an answer of. Now I'm going to give it to 3 sig figs, because I've told myself before, haven't I? Clever me. I'm going to give it 3 sig figs, and the answer on my calculator is 351562.5. So 3 is a sig fig, 5 is a sig fig, 1 is my third sig fig, so I need to look at the next one and see if it rounds up or down. 3.1, 3515 rounds up, so it's 352. And then 000 to get, to remind everyone that this is thousands of pascals. Give me a 0, give me a 0, and give me a 0, computer. Thank you. And the answer there, well, Kp units, pascals times pascals on the top divided by pascals on the bottom is going to be pascals just once as my unit. That's an A, not an O. 350,000 pascals. Hopefully that made sense. Any questions? Put them on Teams. There we go. Now I just need to work out how to stop the video again. How do I stop the video? Where's the little video thing come up? Do I do Windows and something? Windows and Q? No, I don't. Windows and Q, they said. Oh, no, they didn't. How do I do this? You guys can stop the video now. I'm just trying to work out how to stop the video. You don't have to watch this. Oh! Seriously, where's my bloody screen recording? Oh, there it is. There it is.